we're going to focus on something very specific today, and that is why must continuous odd functions always satisfy f0 equals 0, or in other words, pass through the origin. Well, let's start with defining what an odd function actually is. So an odd function is when you have f of minus x equating to minus f of x. I'm gonna draw an example just to help you visualize. Let's say at x equals minus 5, the output is 2. And at x equals 5, the output is minus 2. You can see that with this function, it satisfies our criteria for odd function. So this example is a perfectly feasible odd function. The function is also continuous, at least within the interval that we are concerned about, which is at x equals 0 and positive and negative epsilon away from it. Epsilon just being any arbitrarily small value. Alright, to tackle this question, we're going to try and prove it by contradiction. So we're going to assume that there is a continuous odd function which does not pass the origin, or in other words, f of 0 does not equal 0. Now we know two specific things about this certain function, that f of x equals minus f of x, since it's odd, and that the value that the function outputs at x equals 0 is not 0. To make an odd function that follows these rules, let's say for example, f of 0 equals 5. We draw a little diagram to visualize, and as we tend x to 0 from the left side, f of x should approach 5. Let's say for example, when x equals minus 0.1, f of minus 0.1 is 4.8. Now looking back at the universal feature of all odd functions, this must mean that at x equals plus 0.1, f of x must equal minus 4.8. However, at x equals 0, the function equals 5. So for the function to output minus 4.8 at 0.1, it must have a discontinuous jump at x equals 0. So this function is actually discontinuous, which is a contradiction as we assume that it's a continuous function. Therefore, we can't have both f0 defined and f0 not equal to 0 while satisfying the criteria of an odd function. In this way, continuous odd functions must pass the origin.